Hey everyone, we're going to do writing linear equations part 2 today. All right, we're actually going to do slope-intercept form. So yesterday we did point-slope form, and I know you guys don't know point-slope form as well as you know slope-intercept form, but I actually think point-slope form is easier, and I'm going to show you why today. So we're gonna do slope-intercept form today. So here's slope-intercept form right there. We're actually going to talk about standard form just a little bit. And their standard form right there. So what we're going to do is we're actually going to do all the same problems that we did yesterday, but we're going to do them with slope-intercept form, okay? So why is that harder? Well, slope-intercept form needs the y-intercept. So for this question, right, do they give us the y-intercept? No. Right? We don't know what the y-intercept is. They give us a point and they give us a slope. So the best way to get this into slope-intercept form is actually to put it into point-slope form. So if you want to look, like for example, if you want to look at what we got from yesterday, you can, but in point-slope form, this is y minus 7 equals negative 4. X plus 1, okay? And we're actually going to turn this into slope-intercept form. So kind of the same way earlier this week we turned its standard form into slope-intercept form. That's what we're going to do here. And it's, again, 2 steps, all right? You do want to get y by itself, so we want to get rid of that negative 7, but also we need to get rid of those parentheses because slope-intercept form doesn't have parentheses. So we're going to start by distributing right there. All right, so negative 4 times x is easy. That's just negative 4x. Then we do negative 4 times 1. That's negative 4. Now we just add the 7 over, and we're done. So we've got y equals negative 4x plus 3. So now we know, okay, the y-intercept is 3. All right. And so that's really the best way to do this. There are other ways, but it's more work. For this question, all right, this question is a little bit easier because they give us a point, but look what do we notice about that point? This point is the y-intercept, all right? Remember, if the x value is equal to 0, that's the y-intercept, all right? That means it's on the y-axis. So here, we don't actually need to put it into point-slope form, but it's only because they specifically gave us the y-intercept. So if you notice that, good, you can just put it straight into here. If not, and you put it in point-slope form and solve it, you'll still end up here, all right? So don't worry about that if you don't notice it. But I just wanted to mention this. So there's the first 2. Now, when it comes to a graph, all right, just like yesterday, we need to figure out what the slope is. If you remember how we did that, we picked out 2 points on the graph. We figured out what's our rise, what's our run. So our rise was +2. Our run was +1, right? So therefore, our slope was 2. So we know that for slope-intercept form, it's y equals 2x. Now, when we did this problem for point-slope form, we could just pick any point that we want and plug it in. Not for slope-intercept form, right? You have to pick the y-intercept. So we have to look, where does it cross the y-axis? Right? It crosses the y-axis right there, and that's at 1. So that means our y-intercept is going to be 1. So we're going to say +1. Over here, for a table, again, you got to do the same thing as how we started yesterday. You have to find the slope. All right, so what is the slope? Well, remember, you're going to take just any 2 differences right there. So negative 1 down to negative 4, that's -3. 0 to 2, that's +2. And so we're going to figure out the slope there. Remember, the y's are the rise, okay? That rhymes. So it's rise over run. So your y values go on top. Your y's are the rise. Run is your x values, all right? A good way to remember that is if you see your x, you run, all right? You'll never forget that. So slope, -3/2, so we're going to say slope-intercept form. Y equals -3/2x, And then what is the y-intercept? Okay, so you need to look in your table and see if you can find the y-intercept. So here's the y-intercept, all right? It's when the x value is 0, the y value is -1, so we're going to put -1. So there we can go ahead and get our answer. Y equals -3/2 x minus 1. So next we're going to move on to a couple more. So again, we did this yesterday. So we're going to talk about when you just have 2 points, what do you do? Well, whenever you just have 2 points, all right, that's when you got to use your slope formula. All right, your slope formula is up here. Oops. So if you want to copy that and bring it down, especially while you're doing your problems, you can, but there's your slope formula right there. So these are our x values, these are our y values, all right? And so we just want to subtract, so I'm going to go from this point to that point, so I'm going to do 7 minus 1 over -3 plus 6, right? That gives me 6 over 3, which is 2. We did this yesterday in class, so that's why I'm not spending a lot of time finding the slope. Now, once you've found the slope, what do? Well, we don't have the y-intercept here, do we? Neither of those points are the y-intercept. So what we have to do is plug it into point-slope form. So we're going to plug it into point-slope form just like we did yesterday. So I'm going to plug it into that first point, y minus 1. Our slope is 2. And then we have x plus 6. And now we're going to turn this into slope-intercept form. So just like we did before, we're going to start by distributing to get rid of the parentheses. That gives us 2x plus 12. Now we're going to add 1 to both sides. And that gives us y equals 2x plus 13. And now we are done. So now we've got it in slope-intercept form. So you can see why I said point slope is easier. In order to get to slope-intercept, you've got to go to point slope first. So there's y equals 2x plus 13. We're going to do the same thing over here. All right, so our y values, so we got 8 plus 2. And then we've got -6 plus 2. So that gives us 10 over -4. That simplifies into -5/2. So again, we're going to plug in our points. I'm actually going to use this point here because I think it'll be easier to solve. So we've got y plus 2 equals -5/2 x plus 2, just like we did in the last problem. All right, we're going to start by distributing. So every time you multiply just by that x by itself, it just becomes -5/2 x, right? But now we got to do -5/2 times 2, right? 2 over 1, that is. So what can you do here? Well, we have a 2 on top, we have a 2 on bottom, and when we're multiplying, we can just cancel those out, so it becomes -5 over 1, which is just -5. So we've got -5, y plus 2 stays over there. Now we can just subtract 2 on both sides. These cancel out, so we have y equals -5/2 x minus 7. And we are done. We finally have it in slope-intercept form. Whew, okay. So we have 2 more to do, all right? We have g and we have h, so we're going to keep chugging along, doing the same thing that we did above, all right? We need to use our slope formula. So our y values are -8 and -5, so we've got -8 plus 5, right? Because that's subtracting a negative becomes a plus. For our x values, we've got 10 and 10, so I'm going to do 10 minus 10. And interesting what happens here, okay? -8 plus 5, that's -3. 10 minus 10 is 0, so we have -3 over 0, right? That means our slope is undefined. So how do we write an equation if the slope is undefined? Well, let's go look back up here, right? If you remember, undefined slope, that's a vertical slope. right, it's going through the x-axis, all right, at a certain number. So this could be at -3. So since it's going through the x-axis, right, vertically, this x value is never changing, right? This is this is -3, 1, -3, 2, -3, 3. It's always staying at x equals -3. So this equation is actually, would be x equals -3. So if you remember, we talked about this in our notes, all right, undefined is going to be x equals. So x equals what, right? How do we know what x equals? Well, look at your points, right? X equals 10. X equals 10. It doesn't matter what the y value is, x is staying at 10. So our equation is x equals 10. And if you forget, all right, is undefined x or is undefined y, just look at your points. What value is not changing, right? Your x value is staying at 10, so your equation therefore is x equals 10. If we come over here, all right, and do the same thing, we've got y values of -3 and -3, so that's -3 plus 3. Then we have x values of -2 and of 8, so that's -2 plus 8. So again, what happens on top? -3 plus 3, that's 0. -2 plus 8, that's 6. So this equals 0, right? So what is the equation? Well, look at your points. Y equals -3, y equals -3. The x value is changing, but the y value is not changing. Therefore, our equation is just going to be y equals -3. Okay, so hopefully that made sense to you. If you ever get 0 or undefined, just look at your points, okay, and try and look and see which point is not changing. Is that the x point or x coordinate, or is that the y coordinate? And whichever one it is, that's going to be the letter in your equation. So we're almost done. I know we've done a lot today. We're throwing a lot at you, but the last thing that we're going to do is some application problems. So this is some word problems, and I know how much you guys love word problems. We're actually going to do a lot of word problems this year. So let's go ahead and read this. It says, the Jones are purchasing a new home. The closing costs are $249 plus 3% of the purchase price of the home. All right. Write an equation to represent the total closing costs. So don't say, when am I ever going to use this, right? Hopefully, at some point you'll be purchasing a home. I just did this summer, and I definitely had to worry about closing costs. So what is our equation, right? Well, it tells us the closing costs are $249 plus 3% of the purchase price of the home. So we have two variables here, all right? We have an equation to represent the total closing costs. So we're going to call that C, all right? C is the closing costs. We also have another variable, the purchase price of the home, right? That could change. Every home's going to be different. So we're going to make that other variable P the purchasing price. We have a lot of alliteration in this problem. I don't know why. That's just a coincidence. All right. So what they're telling us is the closing costs are, so we're writing an equation to represent the closing costs. So C is going to go by itself. The closing costs are $249 plus 3% of the purchase price of the home. So we don't want to put a percent into an equation. We want to turn that into a decimal. So if you remember how to do that, 3% is actually 0.03. It's not 0.3, that would be 30%. 0.03, so we're going to have 0.03 times the purchase price of the home, which we called P. So if we want to rearrange this, we could rearrange it to C equals 0.03 P plus 249. And you should be able to recognize here that this is in fact in slope-intercept form. So that's our equation. Now they're actually giving us some numbers to plug in. So it says the purchase price of the home is $195,000. The sellers offered $5,000 in closing cost assistance. Will this cover all their costs? If not, how much will the Jones need to come out of pocket? So the sellers are offering them $5,000, which is weird because that would mean it's a buyer's market, but it's definitely not right now. It's definitely a seller's market. No one would do this. So we just want to see, would the closing cost be more than $5,000? So we're going to use our formula to figure out the closing cost. So we've got 249 plus 0.03 times $195,000. Believe it or not, that's actually a cheap house. So I'm going to get my calculator out because I don't know what 3% of that is. So 0.03 times $195,000. That's $5,850. And that's not even the whole thing because now we have to add 249 to that. So the closing costs are actually $6,099. So no, that will not cover it. They will actually have to pay $1,099 out of pocket because they're only giving them $5,000. But I guess $1,099 is still better than $6,099. So that's the answer to that problem. All right, we have one more. Oh, man, I hope this video is not too long. Last problem says Kylie is a collection of quarters and nickels. Write an equation to represent the total cost. All right, so quarters and nickels. She has a bunch of quarters, bunch of nickels. We don't know how much of which. So again, we're going to define our variable. So what do we not know? We don't know how many quarters she has, so I'm going to make quarters Q. We also don't know how many nickels does she have. So I'm going to make nickels N. And so what is how much money does she have? All right. So we're going to say that is, well, how much is a quarter worth? So for every quarter she has, that's 25 cents. And then how many nickels does she have? Each one of those will be 5 cents. So however many quarters and nickels she has, we'll multiply that by their values and add them together, and that'll tell us how much money she has. So it says if the total value of the coins is $5.50. So they're telling us the total here. So this is a little bit different than the problems before, all right? We know that the final answer is going to be $5.50. It also says she has 17 quarters, so we can go ahead and plug 17 in for Q in our equation. How many nickels does she have? So we don't know how many nickels. We know she has 17 quarters. All right. So we want to know how much money of that $5.50 is with the quarters. So if we multiply 0.25 times 17, that'll give us 4.25. There's an N there, by the way. So out of 550, 425 of that is from quarters, so that's most of it. So now we're going to subtract that out because we want to see how much money is left to be represented by the nickels. So that's $1.25. So $1.25 is worth of nickels. Each nickel is worth 5 cents. So if we divide by 0.05, the answer is 25. So she must have 25 nickels. So there's some application problems right there. All right, I know you guys don't like word problems. That's why we practice them. Go ahead and finish your assignment. You should have done half of your assignment yesterday in class. Today, you will do the other half, which is all the questions on slope-intercept form and the application problems at the end. So if you have any questions, bring them to class tomorrow and we can go over them. All right. Other than that, good luck and have a great